This is a synthesis of warfarin. Warfarin is a blood thinner drug, thus it prevents blood clots from forming or expanding. It is given to people with a regular heartbeat, prosthetic heart valves, and heart attack victims. It's also used to make rat poison. Approximately $7.5 billion of warfarin is prescribed in a single year. It costs about $19 per month as a generic branded medicine. The overall reaction to synthesize warfarin is by adding 4-hydroxycoumarin to benzyl acetone to create racemic warfarin. This is the organic synthesis in which it has 4 immediate steps in the reaction. To make the reaction happen to occur at equilibrium, the reagents are refluxed in water for over 4 hours. Reflux involves heating the chemical reaction for a specific amount of time, while continually cooling the vapor produced back into liquid form, using a condenser. The vapor produced above the reaction continually undergoes condensation, returning to the flask as a condensate. So essentially the water is continuously cooled and heated in a cycle which then carries out the reaction. The usual synthetic route for racemic warfarin involves a base acid catalyzed microcondensation reaction of 4-hydroxycoumarin with benzyl acetone. The yield when the reaction is refluxed with water is 48%. Because warfarin is racemic, it has S and R enantiomer structures, with S-warfarin being 6 times more active for pharmaceutical purposes. In the first immediate step, the hydrogen in the alcohol group breaks away and bonds to the adjacent carbon. In the next intermediate step, the double bond between the oxygen and carbon breaks, leaving the oxygen with an extra electron, as a double bond reforms between the 2 adjacent carbons. The bond with hydrogen on the adjacent carbon breaks as the hydrogen bonds with the incoming benzyl acetone. Benzyl acetone bonds break to prepare for the next step. In the next intermediate ring, the carbon bonded to the phenyl group bonds to the carbon ring. The double bond between the oxygen and carbon breaks into a single bond, and the double bond between the 2 carbons of the formal benzyl acetone compound breaks and the water is formed off of the compound. In the next intermediate step, the water molecule breaks away from the overall compound. Thus the bond that held the water molecule reverts back to a double bond between a carbon and an oxygen. The warfarin compound is then shown with its racemic properties in the final step. The phenyl group determines whether the compound will be S-warfarin or R-warfarin. Regarding the safety of the synthesis of warfarin, the compound is classified as an extremely hazardous substance in the U.S. Emergency Planning and Community Right to Know Act. The Occupational Safety and Health Administration set the limit for warfarin exposure in the workplace as 0.1 milligrams per cubic meter over an 8-hour workday. At levels of 100 milligrams per cubic meter, warfarin is extremely dangerous to life and health. Warfarin is slightly toxic to waterfowl and game birds. Thus, the EPA designated warfarin in the toxic category number 1, which is the most toxic category.